Here's an example on rotations. Triangle ABC has vertices A, negative 8, 5, B, negative 6, 9, and C, negative 3, 6. Move through the steps to graph triangle ABC and its image after a rotation of 180 degrees about negative 5, 3. So this is about a point that is not the origin. The first step is to make a prediction. Graph triangle ABC and predict where the image of ABC will be on the coordinate plane after the indicated rotation. Okay, so we're rotating 180 degrees. When you're doing 180, it doesn't matter if you're thinking clockwise or counterclockwise, you end up in the same spot either way. But we're going to end up completely over here on the other side. B will be around in here, A and C, right? Just taking our image and just whoop, right around the other way. The image of triangle ABC after 180 degree rotation about negative 5, 3 will be a triangle in the third quadrant. Both the side lengths and the angle measures will be preserved, but the position will change. Map the center of rotation to the origin. To map the center of rotation to the origin, translate the center of rotation along the vector 5, negative 3. Then translate the vertices of triangle ABC along the same vector. So the suggestion here is to take your triangle and the point of rotation and trying to make them look the same here, and slide them to the origin. So triangle ABC slides down into this spot. The rotation point of rotation, center of rotation, slides to the origin. Then rotate 180 degrees about the origin. Right, so negative 1, 6 becomes 1, negative 6. Negative 3, 2 becomes 2, negative 3. 2, 3 becomes negative 2, negative 3. Now they show it going counterclockwise. Again, when it's 180 degrees, it's not that particular which way you go, clockwise or counterclockwise, because 180 is still exactly on the opposite side. Think of it as noon and 6 on a clock. Analog clock, not a digital. Then you have to map the center of rotation to its original position, right? So you got to take your whole thing and move it back up to where it was before. To map the center of rotation to its original position, translate the center of rotation along the vector negative 5, 3, then translate the vertices of the rotated triangle along the same vector. So they take the translated rotated triangle and they slide it back up so that the center of rotation is back in its original position and the triangle is now where it should be for the rotation. The image meets the prediction because the majority of the image is in the third quadrant. So when I was doing mine, I went too far down, but that's okay. My prediction was a little farther down. Remember that the process for rotating a figure changes when the center of rotation is not the origin. Triangle PQR has vertices P, negative 2, negative 3, Q, negative 5, negative 6, and R, negative 3, negative 3. Find the coordinates of the vertices of triangle P prime, Q prime, Q prime, R prime, after triangle PQR is rotated 180 degrees about 2, negative 2. So we can't simply just take our X and Y and make them negative. That doesn't work, okay? So we have to be careful and we have to make sure that we are ending up in the correct spot when we get completely done.